Welcome to our complex analysis videos, and we want to look at this question 3. This is talking about integration. You are to evaluate the integral from 0 to 1 plus I of this function z squared dz. Now this is a line integral, and we're evaluating something that is like a slope. There is a curve in between them, and so we are not going to differentiate. You remember we were all this while we are trying to differentiate. We differentiated from question 1a and 1b, where we are trying to find out whether the function is analytic or not. And we come to question 2, we also differentiated. This is partial differentiation actually, where we try to find out whether this function is harmonic. Of course, you have seen that indeed the function is harmonic. But here we cannot differentiate because this is a line. And there is what we call instantaneous change. It keeps changing, so you cannot differentiate in that area in respect to that. So we tend to instead of differentiation, what we do is integration. So in this question 3, we have to integrate from 0 to 1 plus I of this complex number z squared. So let me show you what to do. So the question we have is, let's take pen. The question we have to evaluate is the integral. We have to evaluate this integral, which is equals to the integral from 0 to 1 plus I. 1 plus I of this function z squared dz. Another way of representing this will be the integral from 0. Since this is 1 plus I, this means that the x value is 1 and the y value is 1. So this is simply 1, 1. It is simply 1, 1. And what is z according to our basic knowledge in complex analysis? Z is a complex number, which means that it has both the real and the imaginary parts. So instead of z squared, we are going to have our x plus iy. But in this case, it is squared, like we have here. And now we are differentiating in respect to x and y. So integrating in respect to x and y. So we are going to have vx plus I dy. So this is the first thing that you need to do. Having done this, now you look at what is the slope of the line. I told you this is a line. So we want to find the slope. We are looking at the slope. What is the slope of this line? Since we know that our x value is 1 and our y value is 1, if you have your Cartesian plane, for instance, let's say that we have this Cartesian plane, and this is our x-axis, which is the real axis, and this is the imaginary axis. We call the x-axis real and we call the y-axis imaginary. This is 1, 1, because we are having 1, 1. So this is 1, call this 1, and y here is 1. So something is happening here. It's happening at that line. You can connect it from the origin. So we are interested in this line. So I just wanted to illustrate that. So the slope of this line is nothing but 1. It is going to be 1 since we have 1 along the imaginary axis. So the slope is nothing but 1. And if the slope is nothing but 1, it is nothing but y, because it is on the y-axis. And if it is y, it is also equal to x, because we can see that even the x value is 1. So now we can go ahead to see what happens. So our integral now from 0 is not going to be 1, 1. We want to integrate in respect to 1, which is that slope. And this function we are trying to integrate is nothing but x plus ix. We can represent y into x because here we have said that y is equals to x. So that's why I'm putting x. But we know it is squared. And we still have our dx plus I. Instead of I dy, it is now I dx. I dx. Pay attention here. So that what we are going to have is the integral from 0 to 1. We try to open up this. What we will have is nothing but x squared plus 2x squared I minus x squared. This is what we are going to have when we open up this in respect to what? Dx plus I dx, not I dy, because we say that y is equals to x. So if you observe what happened, we have x squared minus x squared. So that is gone. So we are left with 2x squared I. So now what we are going to integrate, this is equal to the integral from 0 to 1 of what? 2x squared I, 2x squared I dx plus I dx. This can be represented if we separate both the real and the imaginary part. This is from 0 to 1. We will have our 2x squared. So this is negative 2x squared, negative 2x squared vx plus, now the imaginary part, the integral 0 to 1 is still the same 2x, but now it is positive 2x squared vx. Now we go ahead and do our integration. You should know how to do integration. It is just a reverse of differentiation. So if we integrate this, what we will have is negative 2 over 3 cubed in respect to 0 to 1, plus we try to integrate the imaginary part of it. That is 2 over 3 still, but positive x cubed from 0 to 1. This is nothing but negative 2 over 3 plus 2i over 3. 2i over 3, which will simply be 2 over 3 into I minus 1. This is just basic integration. You can watch my videos on the introduction about where I talk about integration and differentiation, in case you have any concern about integration. But this is a complex number. Before you reach here, we assume that you know how to do integration. So this is what you will get as your final solution. So the final solution to this question is nothing but 2 over 3 into I minus 1. And this is how you can evaluate line integral, something that has to do with complex analysis.